All right, well, welcome everyone. My name is Tim Hinrichs. I'm the CTO and co-founder at Styra, and I'm one of the co-creators of the Open Policy Agent project. So here today, we're going to be talking about policy enforcement. We're going to be sort of focusing on Kubernetes and the applications running on Kubernetes. And to do that, we're going to be looking at the Open Policy Agent and using policy as code. So the sort of jumping off point for today is just sort of a very simple observation, which is that all of these mega trends that we're seeing throughout the world around changing how software is being built and run, DevOps and CI/CD and microservices and cloud and self-service and automation. Those are all just fundamentally changing the way that we're building and running software. And it's super exciting, it's a lot of fun to be part of this new movement around software development. The observation we'll make here, though, is that there is, because of all those changes around software development practices, a bunch of changes around security, that fundamentally security is changing in response to a lot of these mega trends that we're also familiar with. And so here down at the bottom, I've sort of called out a couple of them. If you think about the APIs, if you think about how many APIs we have, if you think about the public cloud, you've got literally thousands of APIs in a single large, admittedly, piece of software. If you think about microservices, the whole idea behind microservices is that you have many, many more, maybe 10x the number of different software components, each of which have their own APIs. And so from a security point of view, from a usability point of view, that's wonderful because now we have all these wonderful APIs that we can use to get our work done. From a security point of view, what that ends up doing is increasing the attack surface. If you think about all those APIs that are great for us as legitimate users, if you think about this from a security point of view, those are also that's also a much broader attack surface when you think about an attacker. If you think about the cloud, it used to be we all had control security-wise over our our networks and our data centers, our physical hardware. But now that we move to the public cloud, well, we just don't have control of that. We don't have visibility into that a lot of times. And so again, that's just a fundamental shift in how we think about security. If you think about CI/CD and automation, what that means to me in part is that, especially in the context of the cloud, is that we're spinning up new applications all the time. And moreover, we're spinning those up in new environments, right? We may be spinning up an environment in a country we've never visited before. And so the environments in which we're spinning these new running applications is just far more dynamic than it ever has been before. And if you even think about load balancers and elastic compute, even the environments are changing even based on the load that we're seeing on those applications. And then if you finally think about DevOps and self-service, we've just got far more people now using production equipment than we ever had before. So that's, again, a big change in terms of security. And so there's a bunch of things in security that we could talk about. Today, we're going to be talking about authorization or policy a bit more generally. The idea behind authorization, remember, is that what you're really thinking about in terms of security is controlling which actions are taken. And now those actions could be taken by people, they could be taken by machines. And so it really, from the authorizations point of view, doesn't really matter. At the end of the day, what you care about is which actions can these people and these machines take. And the answers, the decisions to that authorization question are sometimes dependent on a wide variety of factors. Sometimes it's just, can this person or machine execute this API? Fine. But maybe it also depends on the software or the environment that they're executing that API on. Maybe it depends on the resource. Maybe it depends on the time of day. Maybe it depends on 57 other things. And so those authorization decisions that get made are pretty multifaceted in a lot of cases. And what we need to do as practitioners and people responsible for running and building software is impose our will on which actions are allowed or which ones are not. I will contrast this just for the sake of completeness with authentication. Remember, authentication is the problem of who are you, right? Like, how do you convince the computer system that I am Tim while I give it a username and a password and thumbprint, whatever else, multi-factor authentication. So we're not going to be talking too much about authentication today. We assume that's being solved. There are plenty of good solutions around authentication for people as well as for machines. So what we're going to be focusing on today is really authorization. And so I think the claim that I'll make here is that in this new world of DevOps and self-service and so on and so forth, authorization is just more important than ever. And it's just more important because there are just many more people that have access to production software. There are many more actions that those people are taking. There are many more software pieces of software that they're taking those actions on. Many more resources than there ever were in the past. And those environments in which they're taking those actions are wildly dynamic today, far more so than in the past. And so then if I think about a sort of a standard cloud native stack, one of the things that we see is that really authorization takes place everywhere, right? Authorization is one of those foundational pillars of security, and not surprisingly, therefore, it shows up in each and every piece of software that we use. So if you think about like Kubernetes, for example, there's all kinds of authorization. I know Mark was talking a little bit about it in the last session. That, you know, at the Kubernetes layer, you've got authorization sort of at the, there are a couple of different kinds of authorization. The one I'll call out here, though, is just, you know, every time a user tries to deploy a new resource, a new pod, a new ingress to a Kubernetes cluster, is that user authorized to deploy that resource, or are they not? Anytime you think about a microservice application, or even just an application, every time a user tries to take an action or a microservice tries to execute an API call, there's an authorization decision that needs to be made. Is that user, is that machine authorized to perform that API call? Anytime somebody queries a production database or makes a change to a database, obviously there's an authorization question that needs to be solved. Anytime somebody spins up a new public cloud resource or modifies one that exists, again, there's an authorization decision. Anytime somebody SSHs into a Linux box or spins up a Docker container, there's an authorization decision. Is that allowed or not? Even in the CI/CD pipeline, anytime somebody tries to commit a new resource, especially if you're embracing sort of a GitOps model where those resources that get committed to repositories get automatically deployed to Kubernetes, there's an authorization decision that needs to be made there as well. So the sort of observation here is that authorization is pervasive throughout this cloud native ecosystem. And the way that we used to deal with authorization is there were actually a couple of different ways. So one way that we used to deal with authorization was we just used to train people. We just used to say, you know, here are the rules and regulations. Here's a wiki. Here's a PDF. You know, learn this and make sure that when you spin up a new resource on the public cloud, that you know not to open ports that we've deemed are unacceptable. Or anytime you spin up a new resource on Kubernetes, make sure that you know, you've got the appropriate labels and you're using liveness and readiness probes or whatever the rules are for that organization. So that's one option. Another option is sort of the opposite end of the spectrum, is that we actually take those policies and we hard code them into software. So the idea here being that, you know, you could write, let's say, an admission controller on Kubernetes and write some Go code and hard code into that you're only going to allow new resources to be deployed to Kubernetes if they have those liveness and readiness probes and the appropriate labels. Somewhere in between is sort of this configuration option, which is what we see from most pieces of software today. Most pieces of software already have an authorization system built into them. And so what you can do is go ahead and configure those authorization systems to control which people or which machines can perform which actions. Now, the sort of downside to all of these approaches is that either, you know, if you're looking at training people, then, you know, there's no actual enforcement. You're just hoping that people have read that wiki. When you think about hard coding policy, one of the downsides is that, well, now if that policy changes or somebody wants to audit that policy, you got to go and change that. You've got to go and find a programmer to change that policy and then redeploy it. The configuration option is therefore sort of the nice one in between, except the downside here is that each and every product on the planet, each and every project on the planet has their own configuration language, their own way of expressing and enforcing authorization. They have their own API, their own GUI, their own even model for how you think about authorization. And so, you know, here are a couple of very simple examples of policy. You know, only if you're on call can you run production APIs, or can you talk to production databases, or can you, you know, spin up new resources on the Kubernetes cluster. Now, the Open Policy Agent project, which we'll talk about here for most of today, was really designed to provide a unified solution to authorization across all of these different cloud native software systems. So the idea behind OPA is that instead of having, you know, n different configuration languages that you have to learn in order to set up, in order to enforce and audit authorization throughout the cloud native stack, in this case, you have one language, you have one set of tools, you have one policy engine, you have one framework for putting authorization into place across this cloud native ecosystem. And so really the way I like to think about this is, you know, everybody now today realizes that there is such a thing as a Kubernetes manifest. There is also such a thing as an image format called JPEG or PNGs, right? One of the things that OPA provides is a new format for a file called a policy file, which ends in Rego as which is the name of the policy language. And that file defines how you express authorization policies. And those authorization policies are then processed by that policy engine. The idea being that the policy engine is integrated into each of these different pieces of software. And now that one policy engine can interpret whatever policy file you hand it. Moreover, the tools that OPA provides enable you to see and sort of experience an entire life cycle for policy, just like we have an entire life cycle for software. And we'll go into more detail on that in a little bit. All right, so that's sort of the quick overview of OPA, the problem that it solves, and not how it works, but what it aims to do. And so maybe I'll take this moment to see if anybody has questions. Yeah, it looks like we're good so far. All right, so we'll just keep going. So let's spend just a few minutes looking at the community that's growing up around OPA. This is always, whenever I'm looking at a new project that I haven't run across before, this is always pretty important to me. So the first thing to understand is that OPA is a completely open source project. It is owned by the Cloud Native Computing Foundation. At Styra, we founded it back in 2016. We then donated it to the CNCF a couple of years later in 2018. When you do that, most projects go in as sandbox projects. That's sort of like the first of 3 rungs of maturity. About a year later, it moved along to incubating, and that's where it's at right now. Just like many projects, the CNCF has a nice dev stats portal that you can look at if you want to see all the different folks who are contributing to it. So I would definitely check that out here. And then as you can see, sort of here is, if you haven't seen this before, this is sort of, it's probably a little old, the Cloud Native Computing Foundation's landscape. So this is sort of a depiction of all the different projects that exist within the CNCF or that are attached in some way to the CNCF. And so what you'll see here is that, certainly the only one that's at incubating status today that's focused primarily and solely on policy and giving you that sort of unified approach to policy is OPA today. So I definitely we'll see more about that. The other thing I wanted to point out was, in addition to sort of the organization and the contributors to the project, the other super important thing to me is always, who are the end users. I always like to, whenever I'm evaluating a new open source project, I want to look at the end users, who is using it, what are their stories, why did they pick it up, and so I always like to call out here for OPA, dense areas, dense venues where you can find a bunch of different end user talks. And so here, what you see here is I'm calling out a really dense collection of OPA talks from end users is really at KubeCon US 2019. So here, the nice thing is you get a bunch of different folks that are talking about how they're using OPA and why, but you're also getting sort of a sense as to the different kinds of use cases that OPA is being used for today. So maybe if I back up a slide or two, if I think about this collection of use cases here, all of these none of these are just theoretical examples. All of these are examples of where people are using OPA to solve authorization and policy throughout the cloud native ecosystem in production at scale, right? So there is somebody from each of these who's using OPA in production for Kubernetes and for microservices, and for Kafka is probably the most popular one. For Terraform, even for Linux, that's always an interesting one that people end up adding that at some point. And it's certainly for CI/CD as well. So, so if you want to hear more about how people are using that, I'll certainly call out a number of these talks. Some of these talks are very focused on a single use case. I think, let's see, Goldman here was really talking about Kubernetes, very, very important. Yelp here was talking about using OPA for microservices. But then there's some like Pinterest who said, well, we're using OPA for microservices and for Kafka and so on and so forth. And so there are some that actually talk about using OPA and rolling out OPA for a couple of different use cases. And then there's some that are focused more so on a single use case. The other thing I'll call out here is this OPA Summit. So that was a thing we ran that sort of ran at the same time as the KubeCon normal tracks, but like the day before. And that was just a great place to have, you know, half a dozen folks come and really talk about how they're using OPA. Again, mainly end user folks. So if you want to hear from end users about how they're using OPA, I definitely recommend checking out some of these talks. All right, another good chance to stop and see if anyone's got questions. Let's see, I don't see any yet. Okay, so let's go on. So one of the things, hopefully, that's clear at this point is, you know, what the project aims to do: provide unified policy, unified authorization across that cloud native ecosystem. And one of the things that we'll see is that architecturally, the way OPA was designed was very much in keeping with the cloud native and the Kubernetes, I think, philosophies around do one thing, do it very well, and make it easy to integrate and offload functionality to other components. And so here, let's look a little bit at architecture, because once you get a sense of the architecture and how OPA works and how it integrates with some of these different pieces of software, I think that's the best way to get really get a good understanding of how and why and what OPA actually ends up doing. Okay, so this is the picture that I showed a little bit ago. I was a little worried about showing this just because it kind of gives you this sense that OPA is like this centralized system, right? That all of these different pieces of software, that all your Kubernetes clusters are going to have to jump over the network in order to talk to OPA. That all the microservices are going to have to jump over the network to talk to OPA, and that's just not the case. This is sort of a logical picture of what it gives you once you deploy OPA and integrate it with all these different pieces of software. But at the end of the day, what it really does architecturally is it was designed to be a decentralized or a distributed kind of authorization and enforcement model. So the idea here is that OPA was designed to run sort of at the edge, whatever that edge means to you. If you're deploying OPA as part of Kubernetes, then you would deploy one or maybe a handful of OPAs on each and every Kubernetes cluster. If you were running OPA and applying it to the microservice use case, you would run one OPA typically as a sidecar even next to each and every microservice. The idea in both those cases is that, you know, anytime Kubernetes needs an authorization decision, it doesn't have to hop over the internet to grab a decision. It just talks to the OPA that's locally running on that cluster. Same way with microservices. Every time a microservice receives an API call, it can ask a local OPA for an authorization decision. And the idea here, and the same is true for all these different use cases, right? Wherever you can choose to run OPA wherever you want. What we typically recommend is that you run it at the edge. So you push it all the way as close to whatever software needs authorization decisions as you possibly can. So I like to call OPA like a host local cache of the policies that it needs in order to make decisions. And then you run it on the same server as that piece of software that needs those decisions. So the cool thing here is what it's doing is it's giving you two things simultaneously. It's allowing you to sort of decouple, pull those policies out of that piece of software so that you can manage them independently. That's kind of what we saw on the last slide. But in this slide, what we see is that what we're doing is we're running that OPA on the same server as that piece of software that needs decisions from OPA, so that at the end of the day, you get roughly the same performance and availability as if you had just hard coded and left those policies inside that piece of software. So what we're trying to do there is balance those two needs. So we're having independent management and analysis of those policies, while at the same time giving you roughly the same performance and availability that you would get had you left them built into that software. When you know, one of the earliest users of OPA was Netflix, and they picked it up to do this sort of microservice authorization use case. And what they said was, look, you know, they told effectively the same story that I just told, which was, look, if you've got a microservice application, you cannot afford in a cloud native world to for every time that microservice receives an API call to jump over the network to ask, is this API call authorized? You're going to immediately double all your network latencies, and you're going to double the chances that you've got an availability problem. And so, you know, the reason they picked up OPA was because it does have this well-defined language that allows you to go ahead and express whatever authorization policies that you want. And yet at the same time, it is an agent after all, that's in its name. And so go ahead and run it on the same server as that software that needs decisions. Okay, so I think the tagline here that I think is appropriate is it is logically centralized, meaning that you have one framework, one language, one tool set to express and enforce and audit all those policies across those different pieces of software. But at the same time, it is physically distributed, so you get the good availability and performance results that you would need for this kind of cloud native ecosystem. I think we've got a question here. Okay. Okay, so now let's look at in a little bit more detail about how OPA talks to each and every one of those services. Right, so here's our service. Maybe this is a Kubernetes API server. Maybe it's a microservice. Maybe it's your CI/CD pipeline. Maybe it's your Linux PAM module. It doesn't really matter. The way this works is that service decides it needs an authorization decision. And so it goes ahead and it sends a policy query to OPA. That service goes ahead and says, here's a decision, here's the query I need a decision about. OPA returns that decision. And then it's a service's responsibility to enforce that decision. It is OPA's responsibility to make that decision. So that's how we think about that separation of responsibilities there. Now, the interesting thing about that policy query is that policy query, as you see noted there, is really just any arbitrary JSON object. It doesn't really matter to OPA what the contents of that JSON is. OPA itself does not know or understand what the real world meaning of that JSON is. So let me give you a couple of examples. Let's suppose that service is a Kubernetes API server. So the way this works with Kubernetes is that each and every time an end user tries to go ahead and, let's say, deploy a new pod or an ingress to the cluster, the Kube API server goes ahead and sends a request to OPA and says, hey, is this new pod or this new ingress safe to deploy into the cluster? And when Kubernetes does that, it sends over the full 50, 100, 200, however many lines of JSON that represents that pod or that ingress, right? And all of its gory detail, all of that YAML code that we're also accustomed to seeing is what gets sent over to OPA in order for OPA to make a decision. So OPA doesn't really know or understand what a pod or an ingress is. If, on the other hand, that service is, let's say, a microservice, and the service wants an authorization decision for an HTTP API call, well, the service sends over a JSON object that might include the user, the method, and the path, let's say. Again, OPA doesn't know what a user, method, and path are, but nevertheless, it can go ahead and return the policy decision. The reason this works is because I, as a policy author, I, as a person, I, as a human being, I know what a user, a method, and a path mean. I know what that HTTP API means. And so I can write the appropriate logic to make the correct decision and have it returned to the service. So the reason that we didn't build a bunch of knowledge about pods and ingresses and HTTP APIs and Linux into OPA was so that OPA could be applicable to all of these different pieces of software. What we didn't want to have happen is that every time Kubernetes releases a new kind of resource, that we have to go and make some changes to OPA, right? Instead, the flexibility, the power, that the generality that comes with OPA comes from the fact that we didn't try to build in a bunch of knowledge about these different domains into OPA, and because of that, you can apply OPA to a broad range of software. What that does is it puts some pressure then on the policy language. The policy language needs to be fairly expressive. It needs to be fairly powerful. You need to be able to, if you want to write a policy that says, ensure that only images that come from our trusted image registry are deployed onto the cluster. Well, in order to sort of implement that policy, the policy language needs to let me, as a policy author, sort of dig down through those pods and those deployments and those replica set YAML files. It needs to let me pick out that array of containers. And then it needs to let me sort of iterate over all those containers. And for each one, grab the image field. And for that image field, do some string manipulation to figure out whether or not the image is coming from our trusted registry or not. So that kind of functionality is what OPA's policy language called Rego was designed to let you do. So that kind of flexibility is pretty powerful. And just to contrast this a little bit, if you think about all the sort of classic models of authorization, role-based access control, attribute-based access control lists, even sort of IAM models, all of those you can encode in Rego's policy language because it has that kind of flexibility that you need to analyze arbitrary JSON. The third thing on this slide that I'll call out is that data and JSON on the lower right-hand side. The idea behind this is that when we designed OPA, we wanted to make it possible for you to write policies that are what we like to call context aware. So policies that are aware of the world in which they're being evaluated. And that's what that data in JSON is. The idea here being that I'll use an example from earlier. Let's say you wanted to write a policy that says only people who are on call can SSH to production servers, can make changes to our production Kubernetes cluster, and can query our production database. Well, who's on call? Kubernetes doesn't know, the servers don't know, my databases don't know. Even your your IDP or your LDAP, you never store who's on call in there. Really, the only piece of software that knows who's on call is some third-party service, typically like PagerDuty. So what OPA allows you to do is sort of extract that list of on-call people from PagerDuty, let's say, and inject it into OPA through its API. And there are a couple of different mechanisms for doing that. And now OPA just sees that data as JSON, and then you as a policy author, well, we already know that you've got a policy language that allows you to write policy over arbitrary JSON. So now you've just got kind of two inputs. You've got the input that comes from the environment, this data in JSON, and then you also have the input that's coming from the service, this policy query. And then you're free to write whatever policies you like to make the decision that's appropriate for that request. The last bit on the slide that I'll call out here is that the decisions that OPA makes can be any arbitrary JSON value. Now, very commonly, what we see most people using OPA for to start out with are authorization policies. And when I hear authorization, I think when a lot of people hear authorization, they think of allow, deny, yes, no, true, false, ones and zeros, very simple Boolean decisions. But as you can see here, OPA was designed to be a general purpose policy engine. And one of those, what that means in part is that the decisions that it makes can be richer than simply true, false, allow, deny. They can be any arbitrary JSON value. So imagine, for example, that you wanted to write a policy that makes a decision about what the rate limit for this user is, or what the return code for that request was. In those cases, you need to return a number, right? That's not a true, false. That's not an allow, deny. Other cases, maybe you want to write a policy that decides which clusters to deploy an application to. Again, that's a case where you're not just returning allow, deny. Maybe you want to return the array of all the cluster names. Another example is maybe you're actually hooking up OPA to the Kubernetes admission control in the API server. And what you actually want OPA to return is the actual JSON that represents an admission review response. Again, there you need to return a deeply nested JSON object. So in all those cases, OPA allows you to return those objects. And in so doing, again, you've got quite a bit of flexibility in terms of how you integrate OPA with these external services. All right. I've got a couple of examples here to just ground this. So remember, here is sort of our picture of our canonical cloud native stack. And here, let's look at a quick example of how you might integrate OPA to solve a microservice authorization problem. So here the idea is that, oh, and in fact, what I should say is, on that last slide, a question that I sometimes get is, well, like, look, does that mean that I have to change my software service, my microservice, in order to get an integration with OPA? And the answer is no. What we often see people do for the microservice authorization case is to use a network proxy. So there are all kinds of network proxies out there. Envoy, Linkerd, Kuma, Apogee, those are the ones we happen to have here on the slide. But a network proxy's job, remember, is to just sit there and run. Think of the network proxy as running as a sidecar next to the microservice. It's been configured sort of at the IP tables level to send and receive all the network traffic to and from that microservice. The idea then is that you integrate that network proxy with OPA, so that anytime a request comes into the network proxy, it can go ahead and send that request over to OPA and get a decision. Is this API call authorized or not? And if that API call is authorized, it goes ahead and forwards it onto the microservice. Then the microservice just receives an API call and goes about constructing the response the way it always would, and sends that back to the network proxy, and then therefore back out onto the network. And so in this world, you don't have to go ahead and change your microservice in any way, shape, or form. You just sort of intercept the traffic using a network proxy, and then integrate your network proxy with OPA. So this is sort of the network proxy integration. Hopefully that makes sense. And this is how we see a bunch of people using OPA for microservice authorization. The nice thing here is that there is no way to circumvent OPA, right? Some people will sometimes go ahead and think about modifying a microservice. The downside of that then is that we need to make sure that that the microservice on every API call goes ahead and consults OPA. In this architectural option, all of the network is required to go through OPA. All the network traffic is required to go through OPA effectively, and so there's no way to circumvent it. Here's another example. This one is more admission control. I know Mark talked about this a little bit at the last session, where this is sort of where pod security policies come into play. But the idea behind Kubernetes is that if you haven't looked at this in detail for a while, the way that this works is every time a new user tries to, doesn't have to be a new user, anytime a user tries to spin up a new pod or an ingress on the API server, it'll go through authentication and authorization and finally admission. So admission is just one of these places where Kubernetes has been designed to be extensible. And so what we do is we hook OPA into this admission control step. And so OPA effectively receives admission review requests and then sends back responses to that. Again, just like the last one, this is a great integration for OPA because it is integrated natively into the Kubernetes API. There's no way to circumvent this. There's, it's not a proxy sitting at the front of it somehow that people, it's integrated directly into the API server. Here's a third example. Here, in a CI/CD pipeline, we all know how to spin up and run, PR jobs, and so you can do that with OPA as well. So you just imagine some sort of pipeline or some PR check that anytime somebody opens up a PR, you can go ahead and spin up OPA, run it against the policies, and have it check whatever files are in that repository or in that PR. And then again, OPA can make whatever decision you want. Sometimes it'll go ahead and return a bunch of error messages, and you can go ahead and show those as comments effectively in the PR. Okay, so now is another good time to pause and see. Okay, we've got some questions here. In Kubernetes, okay, so Thomas is asking, in Kubernetes, can you run OPA as a daemon set on each node instead of a sidecar? Yep, you can do that too. Oh, maybe I missed that here. So if we look at this slide carefully down here at the bottom, what we can see here is that OPA can run as a library, a sidecar, a daemon, or even as a service sometimes. Architecturally, it's pretty flexible. For Kubernetes, for the admission controller, we usually run like a handful of OPA instances as a service on Kubernetes. So that's fine for that use case. For microservices, we often will see sidecar. Some people, I think Yelp, for example, ran it as a daemon. So that's fine as well. So you've got quite a bit of flexibility there. WASM is a new kind of way that we are starting we're starting to support for integrations. The idea here is that you could, WASM is one of these functionalities that it's effectively a binary instruction format. It's kind of like a mini VM that's got implementations in a number of different programming languages. So here the idea is that it's like even closer to the original process than a sidecar would be. So I guess I think of it as, you could run OPA as a Go library or as WASM, and they're sort of basically in process. And then if you wanted to just jump out of that process, you could run it as a sidecar. If you want to jump a little bit further or save the number of OPAs, you could run it as a daemon. If you're somehow, in some cases, you can go ahead and pay for network hop, in which case you can run it as a service. Okay.
Hey, Tim, there's also a question in the chat as well.
Oh, thank you. Over to the chat. Okay. Is there a world in which OPA integrates with AWS Azure GCP or replacing AWS IAM? Yeah, so one of the things that we see in the cloud native world is that these sort of the externalizing authorization is just through, for example, webhooks. That's what Envoy and Kubernetes do. That's just becoming more and more of the standard for making these projects more extensible. For the public clouds, I think that's I actually heard somebody suggest the other day that there was a way to plug OPA into, I think it was Azure. I haven't seen that myself and haven't had a chance to follow up on it. But again, that's kind of the way that I would think about it, is that that understanding where you can integrate OPA is one of the first things to think about. And as far as I know, AWS nor GCP have hooks to hook into there. Another question, are Okta and OPA similar? Just wondering, since it's the first time I hear about OPA. So Okta, I always think of Okta as really being responsible for single sign-on, so authentication. Remember how we sort of talked about both of those at the beginning, that, it's really, Okta is really responsible for signing in. So when you sign into Okta, or you sign in through, Facebook or Twitter or LinkedIn or Google, you're really, proving to the system, here's who I am. Now, what a lot of these systems will also do is allow you to include a bunch of claims into your sign-on token, so that when all the downstream processes all the downstream software receives that token, they know, let's say, what groups you're in, and then they can make authorization decisions based on the information in that token. So one of the things that we see people do a lot with OPA, especially in the microservice authorization space, is encode a bunch of like those claims into JWT, so JSON Web Tokens, and then they go ahead and then hand those JWTs over to OPA, and then OPA can inspect the internals, and just like I said, the policies you write can then make decisions based on whatever groups show up in that sign-on token. Yeah, that's a great question. Oh, OPA, there's a question, OPA and Gatekeeper. Yeah, Gatekeeper is a sub-project of OPA. It's dedicated to building a dedicated integration between OPA and Kubernetes admission control. Yeah. Okay, great. All right, so time check, we got 20 minutes. That should be good. All right, keep those questions flowing. These are great. All right, let's go back to present. Okay, so what we sort of talked about up to this point is like a number of different ways. We sort of talked about what OPA does at a high level, what problem it was designed to solve. We've seen how you can integrate it architecturally, and I think that certainly seems to give a lot of folks a good sense as to what it does and what it doesn't do, and that's pretty important. The last thing that I want to talk about here, and I think I'm going to spend most of my time here on a demo, but I've got a few slides to go through first, is really talking about, okay, let's suppose you've got OPA in place, you've got it integrated, and now, well, what does that buy you? What is the experience like in terms of writing policy, enforcing policy, and so on, once OPA is installed and integrated? So the way I always like to think about this is, OPA is really giving us an embodiment of policy as code, right? Just like we have infrastructure as code, policy as code is the idea that now you've got a file format, a file that you can put your policies into, and then those policies can be enforced by OPA. And part of the benefit to that is that now there's an entire life cycle that you can choose to put that policy through. And that life cycle, moreover, mirrors that same software development life cycle that we're also familiar with. So there is a requirements gathering process where, just like we talked about a minute ago, when somebody gives you, let's say, a policy that you're supposed to enforce, one of the first things that you want to think about is, well, what are my enforcement points? Where can I integrate OPA so that I can enforce this policy? And then once you go through requirements, then you want to think about, well, how do I author that policy? What do I actually type? And we'll see how to do this in a little bit. I'll do a little live coding if folks are interested. And so what we'll see is that there's a policy authoring stage as well. And then it can go on to like our standard CI process, where now we want to test our policy. Policies, certainly OPA has a unit test framework. We'll go through this in a little bit. But certainly what we recommend heavily is don't just toss your new policies out into the world. You should definitely test them before that. Then you got to deploy your policies. Remember, OPA is running distributed. You may have hundreds of instances of OPA running. So you got to deploy your policies out to all those OPAs. There's also a monitoring stage. You want to make sure those OPAs are healthy and that the last policy they received is functioning properly. And then there's also a logging stage where you want to actually record those decisions that OPA is making, so that you can audit it later or do other things with it. So OPA provides different tools that apply to each of these different elements, each of these different stages of the life cycle. I'll call out here, there is an OPA ecosystem. I've talked about a couple of the most popular OPA use cases, but there's a whole page of, I guess when I made the slide, there were 40 different integrations, obviously to greater or lesser maturity, but nevertheless 40 different integrations that you can find on that page to maybe inspire you and understand what people have done in the past. In terms of authoring, there's support for a number of different IDEs. VS Code and IntelliJ both support the Rego policy language. There's a playground. I'm going to show you that in a little bit. It's a nice way to test out policy and share it. And there's a REPL as well, so a read eval print loop, sort of a command line version of a IDE. In terms of CI, there's some test tools, performance tools. There's a compiler as well. In terms of deployment, this is pretty useful. That in terms of deployment, you can configure OPA to download policies from a centralized location. That's pretty powerful. That's the bundle API. We'll talk a little bit about that. In terms of monitoring, there's a status API and Prometheus endpoints. And then there's also a dedicated logging API. OPA, when it logs, it doesn't just record the decisions it makes in text. It records them in what I like to call high fidelity JSON. So you actually get a JSON object that represents each decision. What input was provided, what output OPA provided, if you want, what revision of the policy was used to make that decision, and so on. So anyway, I want to give you just a quick overview of some of the OPA tooling. That is sort of an overview of the tooling. What I want to spend most of the time on now is sort of like policy authoring. And I think, looking at the time, it's about 10:45. I think what I probably want to do is just skip over a couple of these and go straight to a demo. And then I can talk through some of this stuff as we do the demo. Okay, so let's do that. All right, any other questions while we're here? It looks like not. Okay, good. Okay, so what I want to show here is a couple of things. So one of which is that I'm going to show you, give you a quick intro to policy authoring. And then what I also want to do is go ahead and show you sort of something working end to end, where we're writing policy and then we've already got an OPA running and integrated with actually two different things. So what I've done ahead of time here is I've gotten OPA running and integrated on just a sort of a Kubernetes cluster. We've got an application running on the Kubernetes cluster. It's actually Kuma's sample application. And I also have an OPA's integrated into that application, just like I showed you with the microservice network proxy integration. And then I've also got OPA running as an admission controller on that Kubernetes cluster. So what I'm going to show you is authoring policy for actually, what I can do here, maybe what I'll do first is I can show you a couple of the YAML snippets that I use to go ahead and put OPA in place. So first, let's look at the Kubernetes one. So here is Kubernetes. So anytime you spin up OPA and you integrate it as an admission controller, there are a couple of things to do. This isn't using Gatekeeper, and there's a reason for that. I'll show you, because I wanted to show everything. I want to show all the policy authoring being done through the playground. But so when you spin up OPA as an admission controller, here's sort of like the Kubernetes validating webhook configuration that you would put in place. And that just tells Kubernetes every time you receive an admission request, go ahead and send that over to OPA. And then you can obviously configure that to only send some of the stuff over to OPA as you like. In addition, here there is basically OPA, which is a deployment. You can run as many replicas as you like, as you would expect. And then what you do is you configure OPA to go ahead and pull its configuration from a config map. You could also hard code this if you like, but here's the config map. And the one thing I'll call out here is that there is this bundle API that I mentioned. And so what we've done here in this bundle API is we've configured this particular OPA to pull bundles from the playground. And I'll show you that in a little bit. So what's happening here is that OPA is being configured to download policy periodically from this playground that I'm about to show you. So that's how it gets dynamic policy updates. The rest of this is pretty straightforward. A service that sits on top of the deployment, and then a namespace to actually host all of this stuff, and then a secret. You need a secret in place so that OPA and the Kube API server can communicate. All right. So that's sort of how you might run OPA, sort of a bare OPA as a Kubernetes admission controller. When it comes to the application that's running, I won't go through all the details here, but what I will say is that here we have a deployment, and this is sort of one of Kuma's backend services. So this is the Kuma web application. It's got some backend services. And so the one thing that I did when I added OPA was I just went ahead and added OPA here. And here, again, this is basically the same configuration that we saw a moment ago. In this case, what we're doing though is we're pointing OPA at a different bundle. So this is basically just, again, configuring this OPA to pull and download policy from the playground. And then the idea is that there's also just a little bit of extra to actually tell Kuma to forward all the requests over to OPA, which, oh yeah, here it is. So this is sort of the equivalent or the analogy to the admission or the validating webhook configuration. So for Kuma, it's a proxy template. All right, so that's sort of what you would do in terms of setting everything up. Now let's go ahead and look at the playground. So all of those, both those OPAs were basically configured to pull their policies out of this playground. So this playground is basically just a web application. It's not intended for production. It's just good for testing out your policies. It's good for helping you author policies and to actually connect them sort of as a demo to a running OPA so that you can go ahead and see this all working end to end. So that's what we're going to do here today. So the idea here is that when you're writing policy, I'll call a couple things out here. The package is just a package from a standard sort of programming language thing. You can write multiple policies. You can organize them into packages or into modules as you so desire. In this particular example, we've really got two allow statements that we're writing here. And so allow and deny aren't keywords in OPA. Really, at the end of the day, allow is just a variable. But at a high level, what this policy language was designed to do is to sort of syntactically mirror the real world policies that we all see in wikis and PDFs. So all the statements that you write in a Rego policy are really if statements. So what this is saying is allow is true if all of these conditions are true. Here's another statement that says allow is also true if all of these conditions are true. And so what we're doing here in this first example is we're saying we're going to allow an API call that is a get to /items. And so we're writing a couple of conditions here. The first one's checking that the method is a get, and the second one is checking that the path is what we expect. And then here in the second statement, what we're seeing here is we're going to allow a get request to this URL here, which is /items, and then there's an ID, and then there's /reviews, and then there's another ID. And again, that mirrors pretty closely the two conditions that are written there in Rego. Now, the other thing that I probably should have called out first was that anytime OPA receives a request from Kuma in this case, which is Envoy under the hood, OPA receives the input that you see over here on the right-hand side. And what you can see here is that there's just a bunch of JSON, right? Like you see there's a destination, you see there's some metadata, you see there's a request, and inside the request, there's an HTTP portion of it. You can see the headers if you want. You can also get the method, you can get the path. You can also get the source if you want. So that's kind of the information that OPA's handed. That's that policy query we saw in the slides a little bit ago. And now given that information as input, let's make a decision. Let's write the logic that makes the decision. In this case, we're going to return allow is true or false. One of the nice things you can do here is within the playground, you can go ahead and hit the evaluate button. And what that does is it actually evaluates this policy over this input, and then it spits out whatever results OPA provides. And so in this case, it's allow. So if we want to see this in action, let's click over the actual application. Here's the application. It's a e-commerce app. And as you can see, you can load this page of all items. That was one of the allow statements we wrote. And the other one that we wrote was that we can allow an inspection of one of the actual items in that list. Now, if we want to see this actually change, let's go ahead and change some of our policy. Now, once we change it, we're going to go ahead and publish it. And now the playground's going to give us a bunch of information. This information was what I used to actually set up OPA and install it as I showed you a minute ago. But for now, we can just close it because we've already done that. So now if we go ahead, and it'll take 5 or 10 seconds to go ahead and for OPA to download that policy. And so maybe let's take a crack. OK, so it looks like, yeah, OK, so OPA's downloaded the policy. And now while we could reload the page, what we see now here is that we're getting an authorization error. You're no longer authorized to make this API request. The API request that we commented out there in that policy is exactly, obviously, the API request that's being denied here. All right. Any questions here? Okay. Not so far. All right, let me show you the other half of this very quickly, and then I'll just open it up for questions. So what we see here is a live running application that we are able to manage policy over, authorization policy over, using OPA in the playground. But what you can also do is use that same playground, that same language, that same tool set to go ahead and control the resources that are deployed onto that same Kubernetes cluster where our application happens to be living. So Here is the policy that that we have in place. Oops, wrong one. Here's the policy that we have in place for the Kubernetes API server for the admission controller. And here, this one looks a little bit more complicated. I'll tell you just for now, ignore this top part. This top part is basically just constructing the response, the actual API response that gets sent back to the Kube API server. And so as you can see, the response has to be an admission review object. And so, I mentioned this a little bit ago that OPA can return these arbitrarily structured objects. And here is a good example of that. But when we're thinking about policy, really what we're thinking about for the most part is what are the resources, what are the conditions on resources that we know are unsafe to deploy to that cluster. So maybe, for example, you want to write a policy that says only that all pods must run images from our trusted image registry. Or maybe you want to say that in the second case here, that all pods must have a cost center label. All right, now how would you write that? Well, this looks a little different from the allow statements a minute ago. These are slightly more complicated deny statements. What these deny statements are doing is actually returning error messages that tell the user why, in fact, their resource is rejected, if in fact it is. And so in this case, what you see here is I've commented out the top one, which is, but the one that's below is in place, and it's saying, well, every pod must have a cost center label. And so let's take a quick look at a pod, and then we'll drop into the command line to actually see us trying to create that pod. All right, so here's our pod. As you can see, it's a super simple pod. It's just got an Nginx image, which does not come from our trusted registry. That's coming from a public Docker image. And so what we're going to do here is very quickly look at Kubernetes. So just so that you see, this is the same pod I showed you a moment ago. If we go ahead and kubectl apply pod.yaml, we see that, oh, we get an error. And the reason we get an error is because that pod failed to include a cost center label. And if you remember, that was the one rule that we had in place over here. So we could go into the pod if we wanted and go ahead and add a cost center label. Label cost center. That's not right. Cost center is whatever bar. Let's save it. Let's try to do it again. And then for the labels. Okay, and this time the pod was created. All right. Now, if we wanted to go ahead and put this policy in place, let's go ahead and publish it again. This time we're going to require that all pods also come from a trusted registry. And we go ahead and try this out. Again, giving it 5 or 10 seconds to go ahead and download policy. All right, and now here we see, remember that pod had the cost center label, but it does not have, but now it has that Nginx image, and that fails to come from our trusted registry. Okay, so again, second example, what we see here is using that using the same language, certainly. Certainly we're even using the same playground, the same sort of solution to sort of deploying policy. And now we're applying that to the Kubernetes admission problem. And so again, just to drill that home, one language, one tool set, one framework for enforcing policy across multiple different kinds of software. Okay, so I think with that, I will go ahead and looks like we've got another question. Do I have to stop share? Okay. Andy Smith says, this looks like a really exciting project. One thing that comes to mind is that policies could become quite complex or hard to maintain. Is this left to the implementer, or are there tools, best practices? Yeah, so one of the things that that I didn't do here, maybe I can share this again, is, yeah, just do this whole thing. All right, so, so yeah, if we look at the playground, the other thing that, that we started doing here is providing some examples to help people get started. So the idea being here that, like, if you want to start with like Envoy, and you want to write, think about how do you decode JOTs and use those to make authorization decisions, you've got example to get you started. Same way with if you want to look at checking the contents of a JOT and using that as sort of like a role-based kind of access control. So one of the things that we are trying to do is provide a number of examples and guidance out of the box to, not out of the box is strong, but guidance around tooling and documentation to help people get started in the right way. We've seen that be very useful in terms of providing, I don't know if I'd go so far as to call them best practices, but by at least giving people examples, they have a great place to start. And so the other thing that I'll call out while we're here is if you want a good place to get started, under the documentation, there are a number of tutorials that were designed to help sort of walk you through using Open to solve very concrete use cases. So here, Docker, HTTP APIs, Kafka, SSH, Terraform, Envoy, and then Kubernetes is such a popular example that it's got its own sort of section here where there's where here are the tutorials for ingress validation. So that's a great place to get started. It not only sort of walks you through doing the integration or applying the integration, but also gives you a place to get started in terms of authoring policy. So we found that to be pretty successful in terms of helping people get started. Okay, so unless there are any other questions, I think we will wrap it up for today. So I should show you this slide. So thank you all for joining me and giving me some of your time. Hopefully you found that helpful in some way, and definitely feel free to reach out at Styra or at OPA. Certainly there's a great Slack channel for OPA where there are plenty of folks that want to help you out, or go ahead and ping me on Twitter as well. All right. So thanks so much.